What does a data scientist do? A data scientist analyzes business data to extract meaningful insights. In other words, a data scientist solves business problems through a series of steps, including before tackling the data collection and analysis, the data scientist determines the problem by asking the right question and gaining understanding. The data scientist then determines the correct set of variables and data sets. The data scientist gathers structured and unstructured data from many disparate sources, enterprise data, public data, etc. Once the data is collected, the data scientist processes the raw data and converts it into a format suitable for analysis. This involves cleaning, validating the data to guarantee uniformity, completeness, and accuracy. After the data has been rendered into a suitable and usable form, it's fed into the analytic system, ML algorithm, or a statistical model. This is whether the data scientists analyze and identify patterns and trends. When the data has been completely rendered, the data scientist interprets the data to find opportunities and solutions. The data scientist finishes the task by preparing the results and insights to share with appropriate stakeholders and communicating the results. When the data has been completely rendered, the data scientist interprets the data to find opportunities and solutions. The data scientist finishes the task by preparing the results and insights to share with the appropriate stakeholders and communicating the results. Now we should be aware of some machine learning algorithms which are beneficial in understanding data science clearly. Why become a data scientist? According to Glassdoor and Forbes, demand for data scientists will increase by 28% by 2026, which speaks the profession's durability and longevity. So if you want a secure career, and data science offers you at that chance. Furthermore, the profession of data scientist came in second place in the best jobs in America for 2021 survey, with an average base salary of USD 1,27,500. So if you're looking for an exciting career that offers stability and generous compensation, then look no further. Where do you fit in data science? Data science offers you the opportunity to focus on and specialize in one aspect of the field. Here's a sample of different ways you can fit into the existing, fast-growing field. Data scientists' job role: determine what the problem is, what questions need answers, where to find the data, also the mine, clean, and present the relevant data. Skills needed: programming skills, SAS, R, Python, storytelling and the data visualization, statistical and mathematical skills, knowledge, Hadoop, SQL, and machine learning. Data analysts' job role: analysts bridge the gap between the data scientist and the business analysts, organizing and analyzing data to answer the questions the organization poses. They take the technical analysis and turn them into qualitative action items. Skill needed: statistical and mathematical skills, programming skills like SAS, R, Python, plus experiences in data wrangling and data visualization. Data engineer job role: data engineers focus on developing, deploying, managing, and optimizing the organization's data infrastructure and data pipelines. Engineers support data scientists by helping to transfer and transform data for queries. Skills needed: SQL databases, for example, MongoDB, Cassandra DB, programming languages such as Java, Scala, frameworks, FLC, Hadoop. Data science tools: the data science profession is challenging, but fortunately, there are plenty of tools available to help the data scientists succeed at their job. Data analysis: SAS, Jupyter, RStudio, MATLAB, Excel, RapidMiner. Data warehousing: Informatica, Talent, AWS, Redshift. Data visualization: Jupyter, Tableau, Cognos, Raw. Machine learning: Spark, MLIB, Mahout, Azure ML Studio. The basic skills you need to become a data scientist. Mathematical expertise: there is a common circulated meme about grown-ups realizing that studying algebra was useless because there are no opportunities to use it in everyday life. Surprise! Data scientists need to understand the linear algebra as well as quantitative techniques. A strong business acumen. Data scientists are supposed to derive information that is useful to business and share it with the appropriate individuals and teams. So data scientists need to have a solid business understanding so they can have the correct perspective when making these determinations. Technology skills. Data scientists work with sophisticated tools and complex algorithms, so they also may be called on to code and develop solutions prototypes rapidly. These expectations mean the data scientists should have proficiency in languages like SQL, R, Python, SAS, occasionally in Java, Scala, Julia. Project management. Data scientists must oversee projects that rely heavily on the data they collect and process. It's up to the data scientists to ensure that things are moving forward and everyone is communicating with each other. Differences between business intelligence and data science. Business intelligence is a combination of the strategies and technologies used for the analysis of business data or information. Like data science, it can provide historical, current, and predictive views of business operations. However, there are some key differences. Data science has found its applications in almost every industry. First one, healthcare. Healthcare companies are using data science to build sophisticated and medical instruments to detect and cure diseases. Gaming. Video and computer games are now being created with the help of data science that has taken the gaming experience to the next level. 3. Image recognition. Identifying patterns in images and detecting objects in an image is one of the most popular data science applications. 4. Recommendation system. Netflix and Amazon give movie and product recommendations based on what you like to watch, purchase, or browse on their platforms. 4. Recommendation systems. 5. Logistics. Data science is used by logistics companies to optimize routers to ensure faster delivery of products and increase operational efficiency. 6. Fraud detection. Banking and financial institutions use data science and related algorithms to detect fraudulent transactions. Data science uses via cases uses. Here are some brief overviews of couple of use of cases showing data science versatility. Law enforcement. In this scenario, data science is used to help police in Belgium to better understand where and when to deploy personnel to prevent crime. With only limited resources and a large area to cover, data science used dashboards and reports to increase the officers' situational awareness, allowing a police force that spread thin to maintain order and anticipate criminal activity. Pandemic fighting. The state of Rhode Island wanted to reopen schools but was naturally cautious considering the ongoing COVID-19 pandemic. The state used data science to expedite case investigations and contact tracing, enabling a small staff to handle an overwhelming number of concerned calls from citizens. This information helped the state set up a call center and coordinate preventive measures. Driverless vehicle. Loanway, a sensor manufacturing company, was looking for a way to make sensor technology more cost effective and accurate. They turned to data science and machine learning to train their sensors to be safer and more reliable, as well as using data to improve their 3D printed sensor manufacturing process. Data science career outlook and salary opportunities. We have already touched upon the fact that data science careers are on the rise and overall the market and demand are promising. Data science is shaping to be a secure, stable career choice for at least the next 5 years. Here's a brief look at the salary potential of several choice data science careers courtesy of glassdoor.com. What's the machine learning? How does it work? Machine learning is an exciting branch of artificial intelligence and it's all around us. Machine learning brings out the power of data in new ways, such as Facebook suggesting article in your feed. This amazing technology helps computer systems learn and improve from experience by developing computers programs that can automatically access data and perform tasks via predictions and detections. As you input more data into a machine, this helps the algorithms teach the computer, thus improving the delivered result. When you ask Alexa to play your favorite music station on Amazon Echo, she will go to the station you played most often. You can further improve and refine your listening experience by telling Alexa to skip songs, just add the volume, and many more possible comments. Machine learning and the rapid advance of artificial intelligence makes this all possible. What exactly is machine learning? For starters, machine learning is a core sub-area of artificial intelligence. This is called in brief to be as AI. ML applications learn from experience or to be accurate data like humans do without direct programming. When exposed to new data, these applications help us to learn, grow, change, and develop by themselves. In other words, machine learning involves computers finding insightful information without being told where to look. Instead, they do this by leveraging algorithms that learn from data in an iterative process. The concept of machine learning has been around for a long time. Think of the World Second Enigma machine, for example. However, the idea automating the application of complex mathematical calculation to big data has been only around for several years, though it's now gaining more momentum. At a high level, machine learning is the ability to adapt new data independently and through interaction. Applications learn from previous computation transactions use pattern recognition to produce reliable and informed results. Now we understand that what machine learning is. Let us understand how it works. How machine learning works? Machine learning is undoubtedly one of the most exciting subsets of artificial intelligence. It completes the task of learning from data with specific input to the machine. It's important to understand what makes machine learning work and thus how it can be used in the future. The machine learning process starts with inputting training data into the selected algorithm, training data being known or unknown data to develop the final machine learning algorithm. The type of training data inputs does impact the algorithm. That concept will be covered further momentarily. The input, which is new, is fed into machine learning algorithm to test whether the algorithm works correctly. The prediction results are then checked against each other. If the prediction and result don't match, algorithm is retrained multiple times and until the data scientists get the desired outcome. This enables the machine learning algorithm to continually learn on its own and produce new optimal answer, gradually increasing in an accuracy over time. The next section discusses the three types and use of machine learning. What is machine learning? How does it work? Lesson 2 of 31 by Piria Disani. Last updated on November 22, 2021. 2419314. What is machine learning? How does it work? Previous text. Table of contents. What is table of contents? What exactly is machine learning? How machine learning works? What are the different types of machine learning? Why is machine learning important? Main uses of machine learning, some machine learning algorithms and processes, prerequisites for machine learning, ML. So what next? Machine learning is an exciting branch of artificial intelligence and it's all around us. Machine learning brings out the power of data in new ways, such as Facebook Messenger suggesting article in your feed. This amazing technology helps computer system learn, improve new experiences by developing computer programs that can automatically access data and perform tasks via predictions detections. Table of contents. What exactly is machine learning? How machine learning works? What are the different types of machine learning? Why is machine learning important? Main uses of machine learning, some machine learning algorithm and processes, because it's for machine learning, ML. So what next? Machine learning is an exciting branch of artificial intelligence and it's all around us. Machine learning brings out the power of data in new ways, such as Facebook suggesting articles in your feed. This amazing technology helps computer systems learn, improve from experiences by developing computer programs that can automatically access data and perform tasks via prediction and detections. As we input more data into a machine, this helps algorithms teach the computer, thus improving the delivered result. As if ask Alexa to play your favorite music station on Amazon Echo, she will go through the station you've played most often. You can further improve and refine your listening experience by telling Alexa to skip songs, just the volumes, and many more possible commerce. Machine learning and the rapid advance of artificial intelligence make this all possible. Let us start by answering the question: what is machine learning? Postgraduate program in AI and machine learning in partnership with Period University Explore course postgraduate programming in AI and machine learning. What exactly is machine learning? For starters, machine learning is a core sub-area of artificial intelligence, AI. ML applications learn from experiences and are to be accurate data like humans do without direction programming. When exposed to new data, these applications learn, grow, change, and develop by themselves. In other words, machine learning involves computers finding insightful information without being told where to look. Instead, they do this by leveraging algorithm and that they learn from data in an interactive process. The concept of machine learning has been around for a long time. Think of the World War II. In GIMA, the applications of complex mathematical calculation to big data has only been around for several years, though it's now gaining more momentum. At high level, machine learning is the capability to add up new data independently and through interaction. Applications learn from previous computation and transaction use pattern recognition to produce reliable and informed result. Now we have understand that machine learning is the main thing of artificial. Now we have understand what machine learning is. Let us understand how it works, how machine learning works. Machine learning is undoubtedly one of the most exciting subset of artificial intelligence. It completes the task of learning data with specific input to the machine. It's important to understand what makes machine learning work and thus how can it be used in the future. The machine learning process starts with inputting training data to the selected algorithm. Training data being known or unknown data to develop the final machine learning algorithm. This type of training data inputs does impact algorithm, and that concept will be covered further momentarily. Now input data is fed into the machine learning algorithm to test whether the algorithm works properly or not. The prediction and the result are then checked against each other. If the prediction and result don't match, the algorithm is retrained in multiple times and the data scientists get the desired outcome. This enables machine learning algorithm to continually learn on its own and produce the optimal answer, gradually increasing in accuracy over time. The next section discusses the three types of machine learning and the uses of machine learning. Free course, Introduction to ML with R. Master Machine Learning with R Basics. Enroll now free course, Introduction to ML with R. What are the different types of machine learning? Machine learning is complex, which is why it has been divided into two primary areas: supervised learning and unsupervised learning. Each one has a specific purpose and action, yielding the result and utilizing various forms of data. Approximately 70% of machine learning is supervised learning, while unsupervised learning accounts for anywhere from 10 to 20%. The remainder is taken up by reinforcement learning. One, supervised learning. In supervised learning, we use known or labeled data for the training of data. Since the data is known and the learning is therefore supervised, directed into successful execution, the input data goes through the machine learning algorithm and is used to train the model. Once the model is trained based on the known data, you can use unknown data into the model and get a new response. In this case, the model tries to figure out whether the data is an apple or another fruit. Once the model has been trained well, it will identify the data is an apple and give the desired response. Here is the list of top algorithms currently being used for supervised learning. Polynomial regression, random forest, linear regression, logistic regression, decision trees, k-nearest neighbors, naive Bayes. The following part of this what machine learning article focuses on unsupervised learning. Unsupervised learning. In unsupervised learning, the trained data is known and unlabeled. In unsupervised learning, the training data is known and unlabeled, meaning that no one has looked at the data before. Without the aspect of known data, the input cannot be guided to the algorithm, which is where the unsupervised term originates from. The data is fed to the machine learning algorithm and is used to train the model. The trained model tries to search a pattern and give the desired response. In this case, it's often like the algorithm is trying to break code like the Enigma machine, but without the human mind directly involved, but a rather machine. In this case, the unknown data consists of apples and pears which look similar to each other. The trained model tries to put them all together so that you get the same things in similar groups. The top 7 algorithms currently being used for unsupervised learning are partial lists, squares, fuzzy means, singular value decomposition, k-means clustering, a priori hierarchical clustering, principal component analysis. 3. Reinforcement learning. Like traditional types of data analysis, here the algorithm discovers data through a process of trial and errors and that device the decision what action it results in higher rewards. The 3 major components make up reinforcement learning: the agent, the environment, and the actions. The agent is the learner or decision maker. The environment includes everything that the agent interacts with, and the actions are what the agent does. Reinforcement learning occurs when the agent chooses actions that maximize the expected reward over a given time. This is the easiest way to achieve when the agent is working within a sound policy framework. Now let's see why machine learning is such a vital concept today. Why is machine learning important? To better understand that the uses of machine learning, consider some instances where machine learning is applied: self-driving Google car, cyber fraud detection, and online recommendation engine from Facebook, Netflix, Amazon, etc. Machine can enable all these things by filtering useful pieces of information and piecing them together based on patterns and get accurate result. The processes flow depicted here represents how machine learning works. The rapid evolution in machine learning (ML) has caused a subsequent rise in the uses of cases, demands, and the sheer importance of ML in modern life. Big data has also become a well-used buzzword in the last few years. This is inferred due to the increased sophistication and of machine learning, which enables the analysis of large chunks of big data. Machine learning has also changed the way data extraction and interpretation is done by automating generic method and or algorithms, thereby replacing traditional statistical techniques. Now that you know what is machine learning, its type, and its importance, let us move on to the uses of machine learning. Main use of machine learning. Typical results from machine learning applications usually include live search result, real-time ads on the web page and mobile device, email spam filtering, network instruction detection, pattern and image recognition. All these are byproducts of using machine learning to analyze massive volumes of data. Traditionally, data analysts was trial and error-based, an approach that became increasingly impractical thanks to the rise of large heterogeneous data sets. Machine learning provides smart alternatives for large-scale data analysis. Machine learning can produce accurate results and analysis by developing fast and efficient algorithms and data-driven models for real-time data processing. Pro tip: for more on big data, how it's revolutionizing industries globally, check out our What is Big Data article. According to Business World IT, the global machine learning market will quadruple from USD 7.3 billion in 2020 to USD 30.6 billion by 2024. In this trend holds, then we will see a greater use of machine learning across a wide spectrum of industries worldwide. Machine learning is here to stay. Some machine learning algorithm and processes. If you're studying what is machine learning, you should familiarize yourself with standard machine learning algorithms and processes. This include neural networks, distant trees, random forests, associations, and sequence discovery, gradient boosting, and bagging, support vector machines, self-organizing maps, K-means clustering, Bayesian networks, Gaussian mixture models, and more. There are other machine learning tools and processes that leverage various algorithms to get the most value of the big data. This includes comprehensive data quality and management, GUIS, for building models and process flows, interactive data exploration and visualization of model result, comparison of different machine learning models to quickly identify the best one, automated assemble model evaluation and determine the best performers, each model deployment so you can get repeatable and reliable result quickly, and integrate it into a platform for the automation of the data to decision process. Prerequisites for machine learning or ML. For those interested in learning beyond what is machine learning, a few requirements should be made to be successful in first of all in this field. These requirements include basic knowledge of programming languages such as Python, R, Java, JavaScript, etc., intermediate knowledge of the statistics probability, basic knowledge of linear algebra. In the linear regression model, a line is drawn through all the data points and that is used to compute new values. Understanding calculus. Knowledge of how to clean and structure raw data to the desired format to reduce the time taken for decision making. These prerequisites will improve your chances of successfully pursuing a machine learning career. For a refresh on the above mentioned prerequisites, the Simply Learn YouTube channels provide succinct and detailed overviews. So what next? Wondering how to get ahead. After understanding what machine learning is, consider taking Simply Learn's machine learning certification course, which will set you on the path to success in this exciting field. Master machine learning concepts, machine learning steps and techniques, including supervised, unsupervised learning, mathematical and heuristic aspects, and hand-on modeling to develop algorithms and prepare for your role of machine learning engineer. You can also take the applied machine learning program in partnership with Purdue University. This program gives you in-depth and practical knowledge and on the use of machine learning in real-world cases. Further, you will learn the basics you need to succeed in machine learning career like statistics, Python, and data science. You should also consider accelerating your AI or ML career with postgraduate program in AI and machine learning with Purdue University in collaboration with IBM. Machine learning is the future and the future is now. Are you ready to transform? Start your journey with Simply Learn.